Good afternoon. Welcome to the afternoon session. Right, it's just one class. So, I want to brush up with what we have seen in the morning. We have seen about the revisiting topics of how the data path is being splitted for more number of channels. Beginning from our FTD, TDD till we have seen about hybrid spectrum techniques. This is what we have seen, right? So this could be afternoon session. I want to dump with some maths. So instead, first we will see a mathematical calculation regarding CDMA, right? This maths will be helpful for you to understand, to check the error, to identify the error between transmitter and receiver. I think already you have studied CRC in your computer networks paper, but here it is something different. How they are computing based upon the chip code, right? A simple calculation. Just watch through this animation. That will help you how this code computing is happening, right? So that's a simple multiplication and addition that will give you the stretch, right? I'll share the link too. So next one, what we are going to see is about CSMA. We have seen the animation for CDMA. Here CSMA. Carrier sends multiple access. The basic technique in CSMA is using your pure ALOA. So whenever the station has data, it will transmit. It will wait for the acknowledgement. Still it has not received. It will wait for some random amount of time. Again it will go for retransmission. The advantage is propagation delay is being ignored here. How they are calculating the time difference between the two different data or two different packets. The formula is T equal to C by P. So data rate represents my C, packet length represents my bits. So during that time the packet may colloid, right? T plus T. Actual frame it would be T1 plus T2 Might be if source to identify that T2 is free, it will go for translating. Ultimately, what will happen? There will be a collision, right? So that's a big problem. So channel capacity is not completely utilized. That could be the case that they are representing through this graph. So inception of CSMA starts with this aloha only. But if the channel is free, CSMA will listen whether area is free to transmit. The disadvantageous contents are being used as a parameter for improvement here. Detection delay, propagation delay, time to sense the signal, or how much distance that we need to send the signal. So that could be the two parameters being quoted as a demerit in the previous case has been used as an improvement parameter here. So these are all the different categories that it is ready to sense the channel. So likewise, you could be able to go for variation. One persistent CSMA, right? The channel is idle, it will go for transmission. That's all. Non-persistent CSMA, whenever it receives a negative acknowledgement, the station, base station, it will wait for a random amount of time, then it will go for retransmission. Sorry. P persistent, it will calculate the probability. P, what is P actually? P plus Q equal to 1. So P equal to 1 minus Q. That P represents probability. So based upon the probability, it will go for its transmission. We will see in this. We will see in depth. There will be a merit as well as demerit. So the advanced technique will check for both detection to collision detection. Do that channel will have the history that collision had happened, right? That could be done through the full duplexing method. Listen, we'll talk. Right? So that's what CSMA is CD. So before coming for this type of problems, we'll see animation how a CSMA CD will work.
Especially if the network has a lot of computers that are sending and receiving data at the same time. So you would think that there would be a lot of collisions happening. I mean, there should be data packets that are constantly sending into each other in all that network traffic. But even though collisions do happen from time to time, especially on older networks, the technology was developed to not only help avoid collisions, but also to respond correctly if a collision does happen.
So,
This technology is called CSMA.
so this is the point that I want to stretch it upon. You must know the past history of the channel. Even if collision occurs, that also must be informed, right? That is the point. Here we have stretched it upon.
Failure sense multiple axis collision detection. And this is the access method used on early Internet networks. And when I mean early, I'm referring to have duplex networks that utilize coaxial internet and earlier versions of push-to-pair cable. Now, CSMAC basically works by each computer first sensing if the wire is idle, and if it is, it's sending its data, therefore avoiding.
So synchronize that it's for wireless networks. The same thing could be applicable for our wireless environment. Here, in terms of wire, we have to think about spectrum.
But if you have two computers trying to send data at the same time, a collision will happen. And if a collision happens, computers will wait a minimum amount of time to try to send the data. So as an example, here we have a network of four computers. And these computers are all sharing a common transmission feed, which is a cable. And this cable must be regulated so that no computers send data at the same time, which would result in collision. And when a collision happens, it causes data loss or data corruption. So let's say that this computer here wants to send data. It first, in the sense or listen, there is any traffic on the cable. And if it senses traffic, the computer will wait until the cable is idle to send its data. But once it senses that there is no traffic, it will go ahead and send its data. And as it sends its data, it can listen for a collision. And if it doesn't sense a collision, it knows that the data was successfully sent. Now, in another scenario, if two computers are ready to send their data, and they both notice that the cable is idle, then both computers will go ahead and transmit the data at the same time. But when this happens, a collision occurs. And when the computers that are sending the data detect that a collision, they immediately stop sending the data, and instead will transmit a jamming signal. And this jamming signal is what notifies all the other computers on the network that a collision has happened. And after the computers receive this jamming signal, the two computers that cause the collision will wait a random amount of time before they send their data.
So whenever the collision appears, a jamming signal will be sent. The computers will wait for random amount of time, as well as that random amount of time also would not be unique.
And the wait time must be random to each computer so that the collision doesn't happen again. So as I stated before, CSMAC was used as early internet networks, and it isn't as relevant today due to the advancement in network technology. It was only relevant in the older half-internet networks, where data communicates in both directions, but not at the same time. Today, we use full internet networks, where data can communicate in both directions at the same time. There is also CSMA, which stands for Carrier Sense Multiple Access with Collision Avoidance. Now, this is the access method that's used for carrier transmission in wireless networks. Because just like wireless networks need to avoid collisions as well. So this is how it works. So when a computer wants to send data on a wireless network, it really can't sense from here if there are any collisions on the network because there's no cable involved. So instead, it does its best to avoid collisions altogether. So in this method, when the computer wants to send data, it will first sense if there are any other transmissions happening. And if it detects any other transmissions, it will wait a short amount of time before checking the channel again. And when it checks the channel again, and if it doesn't sense any transmission, it will wait a short random amount of time, and then it will go ahead and send its data. Then once the destination device receives the data, it will respond to the same computer with an acknowledgement, informing the sender that
So here the signal flag is RTS CTS. Request to send, clear to send. Using these flags, they will initiate the virtual path.
receiving the data. But if the sending computer does not receive an acknowledgement from the destination, it will assume that it did not get the data, and it will start the process all over again. Now, another method that CSMA uses to avoid collisions is the optional RTS-CTS protocol, which stands for Ready to Send, Clear to Send. Now, this is an optional protocol that's used with CSMA on wireless networks. This protocol enables a computer.
It's a old video, that is the reason why they are using the term optional, but by default, RTS/CTS is the protocol which would be implanted in most of the wireless routers.
Send out an RTS or ready to send signal to the wireless access port requesting for an opportunity to send out its data. And if the wireless access port grants this request, the access port will temporarily stop all other communication on the network, and then it will respond back to the computer with a CTS or clear to send
So that's an interesting animation on this. So still people are facing this problem when they are working with the CSMA CA. What is that actually? These two problems will encounter. How to clear that problem? First one is hidden terminal problem. Either from A to C or C to A, you are going to transmit. But you could not able to know that the presence of C for A, the presence of A for C. Via intermediate node B only you could be able to say. So A is hidden from C, and for C, A is hidden from it. Okay. So when I'm going to send my signal, first I could able to detect B either from A or C. B only will decide to transmit the subsequent signal. This is what hidden terminal problem. Exposed terminal problem. B is transmitting to A, right? C heard about the transmission. Now C wants to transmit to D. It observes the presence of carrier signal and defers transmission to D because what C can actually do? Start transmitting to A while B is transmitting to A. Since A is out of range for C because hidden terminal. C signals cannot be heard at A, hidden terminal, remember that. But C is exposed to B's transmission. Right? I could able to hear, but I could not able to perform. That is what exposed terminal problem. What about hidden terminal problem? I don't know the presence of the third one. That is what hidden terminal problem. So do not confuse about that. I don't know the presence of the third person. That's what hidden terminal problem. Exposed terminal problem means I know about the data transmission, but I could not able to involve in it. That is what exposed terminal problem. Right. So how to solve that? See that there are two friends. Assume that A, B, C. How could we avoid collision avoidance? Can I want to talk to you? That's the response from Ali. Can I want to talk to you? Right? See that now the middle one is responding using the name of Ali. Ali, let's talk. I'm available. Right? So what does it mean? Really, will come to know that okay, there is a person named Ali who is beneath the mountain, rear to mountain. Right? So that's what the term about the RTS and the CTS. If you are free, you are ready to send. If you are ready to receive, you are CTS. You are ready to receive. That's what RTS and CTS will do the job. So using RTS CTS protocol, how could I able to solve the problem of hidden terminal problem? How could I able to solve? You could able to see that it is ready to send RTS both directions. Who is going to send that CTS within the stipulated time that will reflect its present. Those who are not ready to receive the corresponding CTS within the respective time, which made that it is not available within our range, right? Within our range. So the time delay which is happening to receive my CTS will reflect the presence of a node. That's all. Exposed terminal problem, right? Exposed terminal problem. Who have received my RTS? From whom I have received my CTS? From whom I have received my CTS? This point will stretch me about exposed terminal problem because CTS acknowledgement will have that corresponding person who is ready to receive. So by that, the confusion will not be there for C to involve in the transaction of N. In that way, I could able to solve exposed terminal problem using RTS and CTS. So how I am solving here, from whom I am getting the CTS, by that exposed terminal problem will be solved. Here, if I am going to get the CTS from a node which is longer than the expected duration, ultimately it will reflect the presence of the other terminal. Right? So that could be the point. And so subsequent standards that we are going to learn from IEEE. So what is the basic standard? Normally, while you are going to convey IEEE 802.11b, B represents, people will be conveying it is as a Bluetooth. So many interpretations are ready to come over on that. But on this MAC, the first IEEE standard being derived for PicoNet. Okay, so that's what I 802.11b, especially for high data rate wireless LAN. The basic frequency, you have to remember these facts, right? How spectrum, the path will be divided using FHSS or DHSS. Modulation technique, they'll be using QPSK. So what could be the symbol rate for 11 Mbps data transfer? How many number of states has to come? How many number of maximum bits of information that a symbol could be able to encode? 8 means 2 power 3. 3 bits of information could be able to remove, and the range is 100 meters. So how 802.11b will work? Based on infrastructure or based on other. But common thing is you must have a service access point, right? From there I am getting the internet. It's very simple example. Wi-Fi access point is nothing but our service access point. From where I am getting my internet. From where I am getting my communication between other systems. Right? So in the first diagram you could be able to see BSS. Service access point is in a wired network, but wireless links are communicating with it. Here, two service access points are available in a network, wired network. They are communicating between the extended networks. What is a dark mode? That I could not able to rely upon any service access point. Everything will behave like my BSS. What is the MAC sublayer of 802.11b? It have two modes. One is DCF, second one is PCF. PCF will enable virtual circuit. Okay, it's very simple. Virtual circuit. You remember virtual circuit in your computer networks. DCF represents my propagation delay plus time to respond. So using the two signals, that it is ready to find it out. So what could be my specifications for data rate? So depending upon different type of data transfer speed, the rest of the things will vary. Right? These are things that you have to remember based upon the standards. Right? So FHSS 2.4 GHz band is divided into 75 1 megahertz sub channels. So 75 channels that they will be able to sync, but it cannot support more than 2 Mbps. Okay, so DSSS. So first one is FHSS, this was DSSS. So how many channels? It's going to work with the 1422 megahertz channels. Okay, 1422 megahertz channels. 14 into 22. So here maximum 3 channels will not overlap. So that's the point. What could be the maximum covering range for this? Up to the access point only it could be able to perform. Right? So what is the default chip pin code they will use? 8 bits. So how they are transmitting depending upon the frequency. Just to see the last 2 digits it will vary. 2.412, 2.437, 2.62, but on the same timeline, within the same frequency range. Right? So without overlapping, 802.11b standard is forecasting its multiple access. That's the point. Right? Channel assignment and registration. See, For this, you have lot of protocols are being emerged, right? So when I'm going to access my point, so how to behave, right? I think this one will give you the how they are communicating. So access point is located in the center of each incident. So this is to demonstrate. Already we have seen this. Already we have seen this, but even though we could not be able to take it forward. Excuse me. Yeah. Okay, now, after. So while we are calculating for our cell or cluster head, we have a calculation. I'm sorry. Right. So how my physical layer for Bluetooth architecture is being divided. So these frame diagrams, please remember, carry forward it. So how they are calculating the interframe space. Okay, four types of interframe spaces are there: short IFS, PCF IFS, DCF IFS, extended IFS. So everything is talking about only on time. So I'm going to use my RTS CTS. That's the basic protocol. Back off. That is the term. Remember, back off. A station back off a random number of slot types. So it's like remember the animation that what we have seen. So the random number also could be vary between stations. So that's what the contention window. So how much time it need to make it to empty, that will be decided based upon the random number. That's what my contention window. So using RTS CTS, it's very easy for me to manage. The same thing represented in terms of channel reservation using CTS, RTS CTS. Because these things will help you to remember back of my go back in algorithm. This is my MAC format. And further, we will discuss on subsequent layers in the forthcoming chapters. So before closing this session, I want to show you a industrial visit virtually. Right? Normally we will visit in person. So by this industrial visit, we will close today's session. Please watch it in the Oppo factory to how a smartphone is made from start to finish.
This is theory from Institute and a couple of days ago, we actually got an opportunity to go and check out the Oppo's factory here in Mumbai. And of course, we had a lot of fun. But what we also made sure was that we documented as well as a PC, after we did the physical share with the video. So without any further ado, let's jump into the video and see how smart things are. So we start by the factory sales along with the gap programs and lamination scale up. Now, either our dress and identity was the first part of the factory design. Before that, we did first on the smooth filter which actually keeps the ionize and makes sure we are not carrying the moisture that is coming from the back. The first thing that happens is the process of the content is like this is where the can see this almost in machine and like cartridge going into this process where you see different class logs and different class logs, all different series and everything going onto the chipset to make it. Now, once this chipset and the board comes out, the other chipset is quite often where few conditions actually get used to these then you use it. So once you have all the issues, that includes that is the installation of software. Now, when a lot of factories are taking manually doing this, actually has a massive machine type to work seamlessly. This is really an example of how it works. Now, once the software is loaded into the check for different transactions and see the previous of flow keys and everything. Several different parts of the already working. Also, in this process, there are moments where you have to first, that you don't have them and for the theory, there is very good now we move on to the fourth assembly. This is where we see a sudden jump on the this is where the phone starts. So you start with the display unit, which then you see the visual inspection. Now, after all of this is kept, we have the battery seals, and we also have the back cover funding. Now, after all this is done, we go to the next part of testing where everything from smaller parts to big electronics, cameras, everything is tested using the meticulously designed also for this case of the data, to clear out that what actually uses liquid hydrogen to do the process. Now, while the assembly line only does this testing, there is another test lab which does the more interesting test. And yes, you guessed it right. I'm talking about the breaking test and counter test and extreme level test. These tests also include pressure tests and different ways, different schools. For example, as an here, this over from the lactic exercise and it's similar to the situation where you and it's there is a dust test as well, where the dust storm of sorts is simulated with devices. You have also more detailed camera tests where they place different object numbers as well in front of different sensors. So that camera is not just working, but also performing. There is very good view. Now, in this school testing, apart from the drop test and everything, the codes are also tested. So the group code is actually tested. They were code that goes in and almost 10,000 times. So that's how many times they can test. They're not long, but that's you also have the tumbling. The tumbling is also the 75 times. Now, what you're thinking is like, all our devices do all these tests. Well, no. Well, what happens is that once the device is assembly, you have to so what engineers do is actually take one part out of that, two parts and then take the phone and that. Then even if one of them is on quality, you can move that now, once all of this is done, the devices from the battery that go through are actually provided ion numbers, and then the phones go battery chargers, cables, power, everything. Now, even after all the packaging is done and the bottles are packed and sealed, there are still and as I said earlier, now, one of my
So that's the interesting one that we have come across. So by that I have completed unit 1. Probably tomorrow I will give you some more brush-up sessions with respect to problems alone. I want to give something on problems alone. So all are informed to type your complete roll number in the chat. So everyone be informed to type your roll number and complete your assignments. Don't forget, including external learning activity. External learning activity, don't carry it forward.